So we just have a little bit more left. We got cut off on that last PowerPoint because I went over 15 minutes, which I really try not to do in these videos, but I got a little wordy. So where we left off was talking about causal inference and how ultimately when we want to actually say that one thing causes another, that's a much higher level of research. And in order to do that, we have to rule out all these alternative explanations for what might have caused an outcome. Now, this is a proposed causal chain that just an example of how in something like schizophrenia, you would look at all these different things that begin with the genetics and then maybe certain vulnerabilities and then adolescent maturation and then other processes that would ultimately cause schizophrenia to actually present itself in a person. I'm probably not going to ask you about the proposed causal chain on the test. So the goals of science, prediction. This is our third one. And this is the one that's really getting to that highest level where we're actually saying, all right, does this cause something else? And creating if-then statements about it. For example, does the driver of the more expensive car, is he going to be less likely to stop, particularly if it's a he? Do ACT and SAT scores actually predict college success? Or does smoking predict lung cancer? When we're trying to predict something, it's a much higher level of research. So what we have to do is this last goal of science, and that's to be able to control. If we can control for as many other variables as possible, that we're going to see more of this when we do our experimental research design later on in the class. If we can control for a lot of those other things, then maybe we can come up with a causal conclusion and say, if this happens, then this will occur. So what would we do with the driving situation? Let's say we do an experimental study and we try to control for everything. So we start with a random group of people, 200 people who agree to drive whatever car we give them for a period of 2 years. And 100 of those people, we have 200 people, so 100 of them are randomly selected to get a BMW to drive, brand new BMW. They get to drive that for 2 years. And the other 100 people are randomly selected to get an inexpensive car, but one that would be the same size so we could sort of rule out any other variable there. Then we do driving, a test of driving behavior at the beginning and then maybe all through the 2 year period to see if those people driving BMWs actually become worse drivers. And if so, then we can blame the car. But if we can't, then we're going to have to blame anything else that goes along with why someone who happens to purchase an expensive car would maybe have certain personality characteristics that would predispose them to not stopping at stop sign, not stopping for pedestrians, or not taking their turn at a four-way stop. So in control, we try to control as many aspects of our research as possible so that ultimately we can make that if-then predictive statement. So experimental studies are all about control, and that's what we'll talk about later. We control all the potential influencing variables to make causal conclusions. So going back to a little review here, we have description, just describing driving behavior, explaining that certain people tend to, people that drive certain cars actually tend to have different driving behaviors, and then predicting if this happens, then or if this is the case, then this is going to be the outcome. And then controlling an experimental study where we would control as many extraneous variables as possible so that we could ultimately have that conclusion that we want to draw with our research. And so that's our goals of research or goals of science.